Let's say Mr. Stick finds a treasure map with directions to a pot of gold. The instructions are simple. Start from the house and first go northeast for 1 kilometer, then go 2 kilometers east and X marks the spot. Easy enough, right? Unfortunately, Mr. Stick couldn't keep this secret from Miss Stick, and she's already walking out the door with a shovel. Because she's the faster runner, Mr. Stick has no choice but to find a shortcut. So Mr. Stick calms himself down and realizes that if he went straight to the treasure instead of going around like the map says, he could get there before Miss Stick. But what's the exact direction, and for how long should he travel that path? Mr. Stick quickly figures out he needs help and calls Professor Stick. As it turns out, the path to the treasure can be revealed by vector addition. You might have guessed already, but the two instructions on the map are vector quantities with both the direction and the magnitude. Let's call them vectors A and B respectively. Adding two vectors will get you another vector that will have the same effect as executing the original two vectors consecutively. So when you add vectors, you express the resulting sum by placing the vectors you want to add head to tail, and then drawing a vector from the free tail to the free head. As you can see, the sum of vectors A and B is the shortcut that Mr. Stick so desperately needs to stick it to Miss Stick. If you call the resulting sum vector C, the relationship between these vectors can be expressed as A plus B is equal to C. Since traveling 2 kilometers east first and then 1 kilometer northeast will get you to the same spot, we can also say B plus A is equal to C. So we know vector additions observe the commutative law. But what if our map had an additional instruction that required the treasure hunter to go 2 kilometers south as well? Let's call that one vector D. Well, adding 3 vectors or more is no different from adding 2. Just draw each vector in succession so that the tail of the next vector begins at the head of the previous one. Once you're done placing all the vectors, just draw another vector that starts at the tail of the first vector and ends at the head of the last. That will be the vector sum of all your vectors. If we call this vector vector S, the relationship between these vectors can be written as A plus B plus D is equal to S. And since A plus B is equal to C, if we added A and B first, the result will be C plus D, which by the way is still equal to S. But what if we added B and D first? Let's call that one vector E. We can easily see that A plus E is also equal to S, so we know that order doesn't matter, and that vector sums follow the associative law. Also, you can easily change the magnitude of a vector by multiplying it with a scalar quantity. So if we multiply vector A with a 3, the result will be vector 3A, and this will change the instruction from go 1 kilometer northeast to 3 kilometer northeast. In the previous episode, we mentioned that the magnitude of a vector is always positive. So what happens when you multiply a vector with a negative 1? Well, the magnitude is the same, and still positive by the way, but only the direction is reversed. So negative 1 times A is equal to negative A. This leads to the final point of this episode, vector subtraction. You might wonder why vector subtraction is dealt with under the title vector addition. Well, it's because vector subtraction A minus B is actually adding vector A with vector minus B. So in reality, we're still adding. The only difference is that we're adding vector A with a vector whose direction is opposite to vector B. One final note, can you calculate what vectors A minus B plus B is? Since order in vector addition doesn't matter, we can rewrite the question as A plus minus B plus B. Since minus B plus B will bring you straight back to where you started, the answer of course is vector A. This is all nice and kind of fun, but it still doesn't give Mr. Stick exact directions to find the treasure before Miss Stick and rub it in her face. For that, we need to know what vector components are. So stay tuned and find out in the next episode. Stick Science.